Alrighty, welcome back to part 2 of lesson 9.2.3, understanding square roots. I think we just get right into it where we left off yesterday. Yesterday we were looking at situations like this where I had you write in, the square root of 47, square root of 120, square root of 230, and use some strategies to figure out what the approximate value of those numbers were. Let's do the same thing here. Um, But for problem number 84, we've got 6 different radical expressions. And your task is to figure out between which two whole numbers this square root would fall and which one we think it's closer to. So I'm going to have you copy these down, pause the video, copy these down, and I highly recommend you copy a number line. Make sure it's properly scaled and have it go from 0 to 15. That should be plenty. Um, and then see if you can figure out where each one of these would go. Okay, so I'm going to give you a head start on how we would write these down. And 0 is the square root of 0. 1 is the square root of 1, and 2 is the square root of 4. What I'd like for you to do is complete the upper portion of this number line so it'll make it easier to figure out where each one of these radical expressions, each one of these square roots would go. So I'm going to pause it. I'm going to fill in the rest of this. You pause the video and you see if you can figure out between which two whole numbers each one of these lie on the number line and which one it's closer to. We're not going to predict, or actually, no, it does want us to estimate the value of it as well. All right, so we're going to do the same thing that we did here. So actually, let me go back for a second just to refresh your memory from yesterday. Do I do this? No, I don't want to do that. What do I want to do? I want to get rid of this guy, and this guy. So remember, the square root of 47 is between 6 and 7 because 6 is the square root of 36 and 7 was the square root of 49. So the square root of 47 would have to be somewhere right there. So it's between 6 and 7, closer to 7, and I estimated it to be pretty close to 6.9, within a tenth of that. Okay, so go ahead. I'll pause the video now and you can fill in all of this and come up with your answers, and we'll come back and see how well you did. All right, welcome back. Hopefully you've got everything filled in. Go ahead and take a look and see what I did. What I decided to do here was I would locate where I thought the square root of 40 would go, and I would think that the square root of 40 is going to be somewhere. Actually, let me change this, make it a little bit smaller there. So I think the square root of 40 is going to go somewhere around here. So I predicted that to be about 6.3. It's obviously less than halfway there, so it's got to be 6.2, 6.3, or 6.4. And then if I use the calculator to check that, what is the square root of 40? Yeah, 6.32, so I was really close there. For 95, no, let's do this one. Square root of 95 is going to be somewhere around here. And that's pretty close to 10. It's between 9 and 10. I think it's closer to 10, and it's probably going to be like 9.8 or 9.7. Let me go ahead and check that. Square root of 95 actually is closer to 9.7. But it, when you're estimating, it said here to be within 1/10, so that's within 1/10. So you could have said 9.6, 9.7, or 9.8, and you would have been fine. So it's a bit of a range there that you have when you get to within 1/10. Taking a look at square root of 3, square root of 3 goes right around here. So that's closer to 2 than it is to 1. I call that about 1.7. The square root of 59, where is that? That is like right around here. I think that might be 7.6 or 7.7. Let's see what that is. Square root of 59 is 7.6, rounds up to 7.7. So, but that's closer to 8. Square root of 200 is going to be just a little bit past the 14. I bet that's 14.1 or 14.2. And then the square root of 154 is, now that's almost in the middle there. I'm kind of curious. Let me just look at this. The square root of 154. Oh, that's not right. Move that over. And you can't see the 1 in there. I better do that again. 154. Okay, so you know that says 154. What is that? That's 10 away from 144, and it's 15 away from 169. So it is on this side of 12 and a half. So I would call that 12.4. Let's just verify that. 154, find the square root of that, and yes, 12.4 it is. So once again, for this one, you could have said 12.3, 12.4, or 12.5. This one, you could have said 14.1, 14.2, or 14.3. The one thing that I would say is this, is if you've got a problem like the square root of 50, even though that's probably closer to 7 than it is to 7.1, call it 7.1 because we know it's not 7. Because the square root of 49 is 7. So the square root of 50, even, I guess that would round up to 7.1 anyway. But unless it's exactly the whole number, don't call it the whole number. Call it like 6.9 or 7.1, something along those lines, so we know that it's an approximate and it's been rounded to the nearest 10th. Okay, so that's how we approximate square roots. Using a number line is very beneficial for this activity. Identifying which whole numbers this radical expression falls between, which one it's closer to, and then estimating an approximate value to the nearest 10th. You can usually do all of this without even having the calculator. You'll notice that when I checked with the calculators, I was coming pretty close to it, at least within a 10th. So if you think about it and you estimate wisely, you should be able to get the answer without too much trouble. Okay, so now we're going to use a graph. And for this, I'm going to pause the video and I'm going to ask, that you actually create a coordinate grid. You only need to do the one quadrant where you have positive numbers. So create an L graph, but have your x-axis be the side lengths that go all the way up to 6. And have your y-axis be the area of the square that will take us all the way up to 40. And so what we're going to do is we're going to fill in this table, and then we're going to estimate where these 4 square roots would go on the graph and use the graph to help us estimate the value. So the graph is going to serve as a number line, just like we had in the previous problem, but it's just going to look a little bit different strategy. So can you please, I'll pause the video and I'll fill things in. You pause it and you fill in these blank spaces. Remember, if the side length is x, the area is going to be x squared. So this would be the number 1. 2 squared is 4, and so on and so forth. Go ahead and fill those in. I'll come back in a little bit after I've filled in the table and I've plotted each one of these points on the graph and I've connected the dots. You do the same. Please take these as ordered pairs, your x and your y coordinate. So 0, 0, 1, 1, 2, 4, 3, you'll fill that in and plot those points and try your best to connect the dots. Okay, we'll come back in a little bit. All right, welcome back. Using my little Moby thing, this is not an easy thing to do, the graph. This is probably easier for you on your paper than it is for me. I can do straight lines great, but doing curved lines is kind of a challenge, but hopefully that looks okay. So that looks like the classic exponential growth kind of a curve, right? Where you got 0, 0, 1, 1, 2, 4, 3, 6, 4, 16. I purposely left this one off. I'll fill that in a second. 5 is 25 and 6 is 36. So what is this one going to be? If the square root of 25 is 5, doesn't that mean the square root of 24? And we did talk about this previously in the lesson from yesterday. We estimated that to be around 4.9. So I'm going to now do this one. Let's go to where we've got 24 here. And what does that appear to be on the graph? It looks like this is going to come down to about where 4.9 would be, somewhere in there. Obviously, my graph is not perfect, but you get the general idea. It's supposed to be going right around there, okay? So, it's not perfect when you're graphing using paper pencil, but it is okay for finding estimates, okay? So now let's go ahead and let's use this graph to figure out where would the square root of 10 be? Where would the square root of 15 go? The square root of 5 and then the square root of 33. So let's go down and find, this is the number we're finding the square root of. Here's our point. What does that appear to be right here? That looks like it's about, what would that be, 3 1/3? So is that going to be about 3.1, 3.2? I'm going to say 3.2 for this. What about the square root of 15? Where would that go? Square root of 15, so here's a 15. What would that be approximately? Somewhere around, if that's 3.5, that's 3.6 repeated to 3. Is this going to be about 3.7 or 3.8? Maybe I'll call that 3.8. Where would the square root of 5 go? Square root of 5 is going to be somewhere around here, which looks like it's going to be about 2.2 or 2.3. I'm going to call that 2.3 since that is a third of the way across, and that would be 2.33. Let's call that 2.3. And I'm going to verify this with the calculator to see if I got within 1/10, but I'm pretty sure I'm doing this right. And here's your 33. Bring that over. That is a little bit past the second to the last line, which is going to be right around here. So do we call that about 5.7? 5.7 or 5.8? I'm going to call it 5.7. All right, let's see if we got those close to correct. Square root of 10 is 3.16. I called it 3.2. That rounds up to 3.2, so that's right. Square root of 15, I said 3.8. Technically, it's closer to 3.9, but I was within 1/10, so that's okay. Square root of 5 is actually 2.2. I said 2.3, so I was a little bit high, but it's still within 1/10, so that's okay. And then the square root of 33 is 5.74. I said it was 5.7, so that is correct. It is closer to 5.7 than either 5.6 or 5.8. So a graph can also be used to determine square roots. I do not recommend this being your go-to method, creating a graph like this, but it can be done. So it's just one more method that can be used to find square roots. All right, the last question. How do you find the square root of a negative number? The answer is you can't. Square root of negative 16. How do you find the square root of negative 16? Well, with the square root of negative 16, you would have to multiply a number times itself to give you negative 16 for an answer. So 4 times 4 gives you positive 16, but that's not negative 16, it's positive 16. And then negative 4 times negative 4 is also equal to 16. So how do you get the negative 16 there? You can't. And so in a situation like this, what you get is what we call numbers that are not real. So there's no real number that exists to get an answer for the square root of negative 16. And so that always begs the question, well, what would be an example of a number that's not a real number? And the answer to that is imaginary numbers. And you are going to get into imaginary numbers or complex numbers in high school. So what we have here is a situation like this. Let's take this problem and let's break it down and say the square root of 16, there is a rule when working with radicals that says you can break this down into products. You could say that the square root of negative 16 is equal to the square root of 16 times the square root of negative 1. Negative 1 is the classic imaginary number. The square root of negative 1, we call that I in mathematics. It's an imaginary number. It doesn't exist. It can't ever exist. There is no home on the number line for this number. It does not exist. But there are some interesting things that you can solve, problems that you can work through if you understand the nature of imaginary numbers and complex number systems. So that's why a part of your high school, I think it's probably going to be sophomore or junior year, is going to touch on this concept. So this is I, and this you can find the square root of. That is a 4. So the answer to this ends up being, the square root of negative 16 ends up being 4i. Hooray! We are not going to do this at all in 8th grade. You will not have to know this. Although I would not be surprised if some of you saw this on your Ren tests, and this would have been one of those concepts that you were expected to get wrong because it hadn't been taught to you yet in either 7th or 8th grade. So just keep this in mind. You can never find the square root of a negative number. It's impossible. All of your radicands, these numbers inside the radical sign, have to be positive numbers in order to find the square roots of them. And once you do have a positive number in there, you can estimate the square roots, or you can find the exact square roots if it's a perfect square. All right, so this completes Understanding Square Roots, lesson 9.2.3. Please go look at the homework, do your best on it, and tomorrow we'll go through the review for part 2 of 9.2.3 homework. All right, take care.